3. Acceleration time graphs. The acceleration time graph shows how acceleration changes with time. For uniform motion, the acceleration is always 0, as in figure 2.1k. For uniformly accelerated motion, the acceleration is constant, as in figure 2.1l. We may calculate from the slopes of a given velocity time graph to plot the corresponding acceleration time graph. 4. Relationship between motion graphs. Note the following relationship between different motion graphs. A. Uniform motion. The acceleration is always 0, and the velocity time graph is a horizontal straight line. The displacement increases linearly, and the displacement time graph is a straight line with a single slope, which may or may not pass through the origin depending on the initial displacement of the motion. B. Uniformly accelerated motion. 1. Without change in moving direction. For uniformly accelerated motion, the acceleration is constant and in general non-zero. If the acceleration is in the same direction as the motion, it speeds up. If the acceleration is in opposite direction with the motion, it slows down. The velocity changes linearly, and the velocity time graph is a straight line with a single slope, which may or may not pass through the origin depending on the initial velocity of the motion. The displacement time graph, on the other hand, curves upward for speeding up motions and curves downward for slowing down motions, and therefore motion with deceleration. 2. With a change in moving direction. If the deceleration continues, the velocity decreases and becomes 0, and finally becomes negative. The motion changes its direction. The acceleration is negative as it is in the opposite direction with the velocity of the motion. The velocity time graph cuts the time axis when the object is momentarily at rest. The displacement time graph curves downward, and the displacement drops from a maximum at the time when the object is momentarily at rest. Spend a few minutes on examining example on the next page and finish checkpoint 3 afterwards.